My name is Omar, and for the past 6 weeks, I've had the pleasure of working with Rolls-Royce Motorcars. So, just in case you've been living under a rock, Rolls-Royce sells super luxury cars all around the world. And they've been gathering data since 2003 with the release of Phantom, and we have data for 3 other major releases in 2009, 13, and most recently for Dawn in 2016. And they have a very concrete question. How many cars are we going to sell next? This is a very important question in general, but particularly for Rolls-Royce. Having an accurate sales forecast is crucial for allocating marketing budget. It helps them to set priorities on their production pipeline, and just in general, to improve the customer experience. So the problem that we have looks something like this. We have 4 different models with a certain history of sales, and we're trying to predict where each of these trend lines is going, right? And we have this situation in Western Europe, in America, and the rest of the world. And we want to make a forecast for each of these trend lines. But the thing is that Rolls-Royce can already do this. Each month, the company makes very careful evaluations of their status. They get feedback from customers, they get feedback from dealers, and they can make a very good estimate of where the company is heading. So really, the question we're trying to answer is, can data science do any better? And this is a very challenging problem. First, as I said, there's a benchmark, right? We need to offer an improvement over the current method, and bear in mind that these people have been in the business for decades. 2, we need a long-term forecast. If this is going to be something useful, we need to predict not 1 nor 2 months, but at least 3 months ahead. Anything less than a quarter is not enough time for the company to react. But by far, my biggest challenge is data. Sure, Phantom was released in 2003, but quarterly data for a model like Dawn, released in 2016, means that my data set had about 8 points. 8 points to train and validate a model. So if you are into big data, this is probably not your talk. That being said, small data sets are quite common, and especially in time series analysis. And there are many things that we can try. So let's see how they perform. Let's imagine that we get in our forecasting car, and if we were driving at top speed, that means that we are making a perfect forecast, predicting exactly every time. Popular methods will take you about there. Initially, I thought this was quite okay, but it turns out that Rolls-Royce is doing around there. And if you're thinking, oh, you should have tried neural networks, or you should have tried XG boosting, whatever, I tried. Nothing came as close as what they can do. So if I want something that can perform nearly as good as what they do now, I need to dig really deep. What we need is something called hierarchical modeling. And to implement this, we need to use a programming language called STAN. What hierarchical modeling does is that instead of considering each model individually, I'm going to share information all around the world. So I'm effectively learning from data not only across time, but also across the space. And when I do that, my needle moves from there to there. I know that seems like a very small improvement, but if you take into account that this is a fully automated process, and if you know how much each car costs, a small percentage is not that small. But I can do better, because now that I know how to extract all possible information from my data, I can distribute it properly. So I will prioritize regional information over global information. And when I do that, my needle moves from there to there. This is truly predictive power. This is great news for Rolls-Royce. And it gets better. Because you see, STAN is not a black box, right? I can look into my model and understand very well what is happening. So I noticed that I can actually extend my algorithm to predict not 1, but 2 quarters ahead. I'm giving Rolls-Royce 6 months of predictive power to anticipate very well to any risk and to take advantage of every opportunity. We are no longer reacting. We are anticipating every problem. As an example, this is a set of predictions made by Rolls-Royce over a year, and this is what my algorithm is given. They're actually very close to each other. But the question is, which one is closer to the truth, right? my algorithm follows the trend line very close and reduces the error by more than 50%. And all of this has been deployed into a dashboard which they can use, and one person with a click of a button can do a job that used to take weeks in under 5 minutes and bring customer experience from here to here. Thank you.